I will just do some introduction to the next part that is going to be presented by Hampus. So he's going to show some plugin development. And so this part will be basically not anymore purely user-oriented, but is also developer-oriented. So he will show and go a little bit in technicalities of coding and how to get a plugin working. And again, there is in the dedicated folder in our repo a step-by-step documentation compiled by Hampus that is basically, he will also go through that during the part of the hands-on, and is always available there just to have it available also afterwards. Okay, so what is this part about? It is describing how to deploy and really start using your plugin. This means that it's not really going into the details of all the functionalities we can actually code into the plugin. It's just giving that for granted because we already explained it in the previous tutorial, the number 12, that is available in the YouTube channel. And so he's giving this for granted and just going and wrapping all this code, this Python code up in some package that is then our plugin. And yeah, indeed, what among all the concepts that he will mention, there are also these 4 kinds of plugins that that Hampus will go through, and he will choose a schema plugin. So these are the 4 kinds of functionalities that we can, with which we can flavor our plugin. And if you want to know more, you can also follow this link to this specific page of our documentation that is explaining you better what is that about. So the schema plugin is, let's say, maybe the easiest part of them, but it's just an example to show how to package your code. Okay. Also in the step-by-step documentation and also in the README file in the root of our repo, there are more links to these software development tools that we are using to develop this kind of infrastructure. So if you want to know more, you can find all the links to this concept just to know more about that if you want to get acquainted with that. Okay, so I will again leave here the links to the community plugins that we're developing, as it is very important to us. If you go there and check them and open issues, because this is what is making a plugin a community plugin. And so these are the 3 I already mentioned. And I'm also leaving here another link to one specific plugin that we are developing for the ICAZ Institute. And this is showing you how we are structuring one plugin and how we are inheriting classes from the 3 community plugins. And so this can be a good primer for you to look at. Okay, so I will leave the screen to Hampus.
Like Andrea said, we have this GitHub repository where we have a README detailing all the steps that I will go through now in the tutorial. So I posted the link in the Zoom chat. So I would highly recommend you to go here if you want to follow along, because there are commands that you can directly copy further down here if you want to follow these steps. If you're watching this video later, there will probably be a link to this repository below the video. So in this part 3, we will go through how to develop a NOMAD plugin. So we will not focus too much, like Andrea said, on the details of how exactly plugins work and what exactly you need to do to get certain parsers or so working, but it's more about the general development procedure to get the plugin ready for actually being used on an Oasis. That being said, we will use some sort of example for this, right? So I will actually use this sintering example that that Sartak showed in the part 2 of the tutorial. But before we start, there are a few prerequisites. So if you want to follow along, you will need to have a GitHub account, which just can be created for free on github.com. And all this development is done in Python, so some basic understanding of Python will be helpful. That being said, you can of course also listen along if you just want to know how this works. And then finally, like I said, I will not go into detail in the NOMAD meta info. So long term, it might be good to also read up a little bit more on the NOMAD meta info. For example, tutorial 8 is good on this, and this you can do afterwards, and then you can come back to this README and continue. And then there are some links here as well for some of these technical terms that I will be using. In case you're not familiar with them, you can go back and read more afterwards. But I will be trying to provide full commands that you can copy so that you can at least follow along, even if you don't maybe understand every single step in the way. Okay, so what we'll be doing in part 3 is that the first step we will do is we will try to create a GitHub repository to host our plugin so that we can later on share it. And the second step is to generate the plugin structures, all the boilerplate code that we need to get the plugin ready for being deployed. And then we will set up our development environment. In this case, it's a Python environment. The fourth step is that we will import this YAML schema that Sartak already showed in part 2, so that we can just use this directly without having to write it again. And then we will add some functionality to this. So like Sartak was showing in the XRD use case, or like Andrea and Sebastian were showing in the slides, we will try to add a little bit of functionality. And then finally, we will test this functionality. This is the outline of part 3. And then I will try to make some pauses between each step and ask you guys if you have any questions or you're running into any problems if you're trying to follow along. So the first step, like I said, is to create a GitHub repository. And for that, we have actually prepared a GitHub template that you can use. So this is this NOMAD plugin template repository in the FAIRmat NFDI organization. But here's just a link. So I will just go ahead and follow this link here. And if we open this template repository, we see a big green button in the upper right corner here saying use this template. And this is exactly what we want to do. So we click this use this template and we say create a new repository because we want to create a new repository for our plugin. And when we do this, we get this questionnaire by GitHub asking us some questions. The repository template is the one already predefined. And then we just go ahead and fill a name for this. So I will call this NOMAD sintering, as we are doing a sintering experiment here. You can give it some description, would probably be nice long term, and then you select whether it's public or private. I will keep mine public, but it is also possible to develop these private in case you have some custom code which you want to, or proprietary code which you want to run in there. I will go ahead and then click the green button at the bottom here saying create repository. Okay, and then after a few seconds here, GitHub will generate our repository, and we have our NOMAD sintering repository here. Right now, this repository doesn't really include much. It's a license file and just a README here, where some instructions on how to use this. We will follow the instructions in the tutorial repository though, and there's nothing really more than that. But we have created our repository. That's the first step. The tutorial, jumping back now to the tutorial instructions. And the second step, like I said, is to generate the plugin structure. I will just check. This was a very quick part, but if someone has any problems that they cannot generate it, maybe they just drop a line in the Zoom chat. Then we will, one of our guys will help you with how you can create this repository. Okay, but moving on to the plugin structure here. Now we will use something called Cookie Cutter to actually generate all of the code that we need for the plugin to get this running. And there are two places where we could do this. So either we can do the common or the normal way, so to say, which is to just clone our new repository locally. However, to run some of the NOMAD functionality, we do need to have a Linux computer. It should also work on Mac, or if you have a Windows computer running some sort of Linux environment, like a Windows subsystem for Linux or something like this, then you can also follow along locally. However, what I will do in the tutorial, and what I could actually recommend, is to use the GitHub code spaces. So this is a coding environment directly in the web browser, and this means that we've already set up all the stuff that you need so that you have the right packages and so on available. So this is what I will show right now. So to do this, I head back to the repository that I just created here, NOMAD sintering one, and I click the code button here in the green here. And then I switch from the local tab to code spaces because I want to run a code space here. And I just click this green, create a code space on main button. Click this button, and then GitHub will go ahead and create a code space for us. And this takes a minute or two to set this up. So while this is being set up, I will just quickly show how you would do this if you prefer to develop this locally. So to do this, I just head back to the repository again, and instead of the code spaces tab, I will use the local tab. And then I will just go ahead and copy this path here. Then I will open a terminal on my computer, navigate to where I want to place my repository, and then I would just do a simple git clone, and paste the path from the repository, hit enter, and then we will clone into a folder called NOMAD sintering, and then we will simply go ahead and navigate into this NOMAD sintering folder. And if you are developing this locally, you will also need to install something called Craft. And Craft is what we are using to generate our instance from the cookie cutter template. If you use code spaces, you don't need to worry about this. This is already set up for you. But if you are running it on locally, then you should do this. So I recommend to install this with pipx. If you don't have pipx, then you also need to install pipx from your package manager. But if you have pipx, then you can just do pipx, install, and then Craft. So I already have it installed, but then it would install it. Alternatively, if you really don't want to use pipx, there are also instructions here. You could also install it with your user with python-m pip install user Craft. Okay, but I will go ahead and go back to the code spaces, and now we can see that the code spaces has loaded up here. So this is basically a VS Code in the web browser that we get access to here, where we can both navigate the code that we have in our repository, but also run some of the code here in the terminal, which is a cool feature. So I will go ahead and zoom in a little bit here by clicking Control+. Let me know if you have a hard time seeing anything of this. Here we get also now loaded up the README, where there are also instructions actually for how you should run this Craft create and all of this stuff. Again, I will for now use the tutorial instructions for this instead. And if we jump back to the tutorial instruction, we see that the next step here is to run Craft. So this is 2.2 here. And to do this, we simply write Craft create, and then we give the path of the Craft template. In this case, this is on the FAIRmat NFDI organization, the cookie cutter NOMAD plugin. But I will just go ahead and copy this command right here so that I can just go ahead and paste it directly into my terminal here. Go ahead and click enter. And then Craft will go ahead and ask us a couple of questions that we can answer. And based on these answers, it will create the plugin structure for us. So first thing it asks is for my name here. So we go ahead and put in my name. And these metadata will be used to fill out information in the Python package so that people know who to contact for if there are any problems and so on. So here you can, of course, just fill in as much information as you are comfortable with filling in. I'll fill in my name and my email here. And then for the GitHub username, if you're doing this as part of an organization, then you should fill up in the organization name here. But I'm doing it on my private GitHub account, so I'll just put my name, my GitHub username here. And then we need to give the plugin a name. So I will just call mine sintering. You can call it something else if you prefer. And then the second thing is the module name. And this needs to be slightly different because it needs to be a valid Python module name. So we do some checking here, but it should be a good default behavior here. So if we just want to have the default, we can just go ahead and click enter directly. And then we should give a short description. So this is a schema package plugin for sintering or something like this. Here, and click enter. We can select the version. I'll just go with the default here. And then we can select the license. So you can choose here a little bit between different license options. I will just go with the MIT license. That's the most permissible in this case. And here comes now some questions about what type of plugin that we are developing. And like Andrea mentioned, there are a couple of different ones. And in tutorial 12, there are some more details about this. Also in our docs, there's some more details about the difference between these different ones. For this tutorial, we will just do a schema package. So we will just create the schema. And so I will answer yes to this first one here, include schema package. And then we'll answer no to normalizer, no to parser, and no to app. And when I do this, then Craft runs. and it creates this folder for us here called NOMAD sintering, which you can see up here in the left. And we see here a bunch of files. And in a moment, I will go through and explain all of these files, so don't worry about that for now. But before we do that, actually, we would like this to be on the top level. So you can simply, if you want, just drag and drop it out. Otherwise, we've also prepared a little script, so you can just write sh, and then whatever path you have to your package here, NOMAD sintering in my case, and then there should be a move template files.sh that you can just run. So we'll just go ahead and run that, and then we see that we have moved everything here to the top level. Okay, so just to reiterate now here, we created a repository, and then we started using GitHub code spaces. Briefly show you how you could do this also locally if you prefer that. And then I ran craft using craft create, answered a bunch of questions here, and then I got my plugin structure here with a bunch of folders that, again, I will explain in a moment what all of these things are. One final step before we go on to the next part, it would be good to also commit what we did. So we are using Git. So if you're not familiar with Git, it's a way of versioning, controlling our code. And we would want to now add these changes that we did to our Git, commit these changes, and then push them. So I will go ahead and actually just copy these lines of codes that I have put here. But this is basically what it does. It adds all the files. We make a message here, and then we push this. So again, I will just go to my terminal here, and then I will paste this in here. And now we can see that this green highlighting here, which was basically telling us that all of these files were new, is gone. And we added this stuff. Okay, so now if there are some questions or if someone has gone stuck, we could have a short time for this. I don't know if there's anything in the something in the Zoom chat, and there also doesn't seem to be anything in the Discord channel. So then I will move on. Again, if you have some questions, I will have another break in a moment where you can ask them more, or you can drop the questions in the Zoom chat or in the Discord channel, and one of the other guys will probably help you out. Okay, so now we have our plugin structure. And before I go ahead and show you what is in here, we will just set up the Python environment because this takes a moment or so. So whilst that is running, we can have a look at what all of these things are. So what do I mean by setting up the Python environment? When we want to develop, it would be good to have a dedicated environment for the Python where we just install the requirements that we need to make sure that everything is reproducible. We also want to use Python 3.9 for this, just to make sure that NOMAD runs as expected. So the way you do this is that you just run this BNB. You can, of course, use, if you want to have some other type of Python environment, use that as well. I'll just go ahead and copy these codes here and run these. So now we have created a .pynb environment up here, and we see that this Python environment has been activated by running this source bin activate script here, and we see this by the .pynb in front of the command line here. Okay, so now we have our Python environment, and what we have created here is actually already a Python package, like the ones you would see on PyPI or something like this. So I will just go ahead and actually install this Python environment here together with all the requirements. And to do this, you just run the pip install, and then we will give the -e flag to make this in an editable mode. And this means that we don't need to reinstall it every time we do any changes. I will also install the development dependencies, and I will provide an index URL to make sure that we get the latest version of NOMAD Lab. If you're doing this in the future, so if you're watching this video later, then probably you won't need this because we will have updated the NOMAD version. But for now, you should use this. The easiest way is probably to just copy paste this again from the README. I will go ahead and paste this in here. And this will take a moment to run because the NOMAD Lab package is rather big. So whilst this is running, we can go ahead and have a look at all of these files that were created by the craft. So at the bottom, there's some requirements for the docs here. This is not so important right now. I will not go too much into the details of the documentation in this tutorial, but there are other documentations about this documentation, right, on our NOMAD docs. The first file here that we have a look at is the README. So here's a README with some instructions. So it's already been filled out for this package. And here there are some instructions again that I was just showing you about how to set up the Python environment, how to install this with the right index URL, and so on and so forth, and a bit about testing. The next file is the pyproject.toml. And the pyproject.toml is what makes this a Python package so that we can install it. So if you've ever used Python before, you've probably run this pip install numpy or something like this, right? And this is possible because we have this pyproject.toml telling setup tools what is this package, right? And this project. Here we have a bunch of metadata. We have this metadata that I provided. So for example, who is the author and all of these things from the craft. We also have things like the dependencies that we need. So in this case, we require NOMAD lab here. We also have dev dependencies with rough and pytest and so on here. And then at the very bottom here, we have something quite important for the plugins. This is actually new for the an updated plugin structure. So if you have already been using NOMAD plugin, then this might also be new for you. So we are now using something called entry points in order to tell NOMAD that some of the stuff in this package here is actually something that NOMAD should plug into NOMAD. And we do this by giving this entry point NOMAD plugin here. And we can see that there is an entry point in here for a my package. And I will show this later. And this is also later where we will add our schema package that we are trying to develop. Then there's this bash script, which we use to move template files. This you can delete if you want. Again, there's some stuff related to the docs here on the left. We don't worry about this for now. There's a manifest just telling what to include. And then against the license file. So in this case, I chose an MIT license, whatever you chose will be there. Some git ignore. And then there's a craft file here. And this craft file is giving you the possibility later to also update this repository based on the template. So if we do some changes, there will be a pull request method and so on. Again, more details in the documentation about this. And then there are 3 folders here: tests, source, and docs. Again, docs I will not go into too much, but in tests folder here, we have all of the things related to testing out this plugin. And we have, for example, a data folder here with some test archive. We have some test code that can be run. And then we have the source folder. And in the source folder, we have our main package, so the NOMAD Sintering. This is the package that is being created here. And we have the schema packages, which is what we are developing here. So if you were doing parsers and these other options, then these would show up here. And inside of these schema packages, there are 2 files. So there is the my package and there is the init file here. And if you have a look at the init file, then this is also new for people who have done plugins with the old NOMAD method. And in this init file, we provide some metadata around our package so that NOMAD can understand that this is a schema package and how to load the schema package. So we do this with, we load this lazy loaded so that we don't have to load everything on the startup of NOMAD. And we also create an instance of this. But I will go through a little bit more details of this later on when we actually create a copy of this for our own schema package. And then finally, we have an example package here. So if you look at this one here, we see that we have a schema class with some quantity name and a message quantity here of type string. And then we have some function which populate this message with hello and the name of the person. So this is an example so that you can see a little bit how this is being run. Okay, and in the meantime here, we can see that now our installation is done. So we have installed everything that we need. So now we actually have a Python package here, right? And a plugin. So we have a plugin with this my package and everything is already. But of course, we want to add something new, right? We don't want to just use this. So let's move on to the next step of the tutorial. Before that, if someone has some questions again, see that there is now a new message. I don't know if this is something has Schema was asking something, but answer that is about the requirement and so on. Yeah, for now, Python 3.9 is what we recommend. So there can be certain issues with certain packages when we move up to 3.10 and so on. In the future, this will probably change, and there will also be support for newer Python versions. But for now, I would recommend to stick with Python 3.9 to get the same behaviors I am getting here. I also don't see anything in the Discord. So then I will go ahead and move on. So just to recap, we now created the plugin code. We also set up our Python environment and installed the plugin into this Python environment so that we are ready to develop this. And what we will do now is that we will import the YAML schema from part 2 of the tutorial. So if you remember, we had this schema that Sartak was showing, where we had a temperature ramp, and we also had a sintering. And in the temperature ramp, we had some initial temperature and a final temperature. And in the sintering, we had a repeating subsection of such temperature ramps. So we will go ahead and we will use this YAML file as our starting point and convert this to Python code. And in order to do this, we want to have this YAML file in our repository. So either you could go and download this from the files thing here and upload it, or you can use the curl command that I put here, which is basically just going to our repository here and copying this file over. So I'll just go ahead and copy this here and run this command in the terminal here. And now we can see that we have a new file here, sintering archive.yaml. And if we look into this file here, we see that we have our tutorial 13 sintering schema, and we have everything that we had from before, with the initial temperature and the final temperature and the sintering and so on. Okay, going back quickly now to the outline here. The next step that we want to do is we want to convert this YAML file into Python code. If you're watching this video later, then hopefully this functionality will be included in the NOMAD CLI, so you will have it directly from NOMAD. For now, this is in an external package, but it's available on PyPI. So we can just install this with pip install and then the name of the package, which is meta info yaml to py. So I will just go ahead and copy this line of code here, and then I will paste this in here. And then I will run pip install, and we will see that we have installed now meta info yaml to py. And important here is that you're using version 0.0.12 or later. So if you have an old installation of this, you should update to have the 12 version here. Okay, once we have installed this, then we are ready to convert our archive.yaml file. And the way that we do this is that this meta info yaml to py exposes a function called meta info yaml to py, where we give it the path to the YAML file that we want to convert. So it's the sintering archive.yaml. And then we can give it the output directory where we want to save this. So I will actually go ahead and put this directly in the source NOMAD sintering schema packages next to this my package here. So I will put source, and then I will put NOMAD sintering, and then I will put the schema packages, and I will put it in there. And then before I hit enter, I will also give one additional flag, which is the N flag. And this adds this empty normalize function. So this is where we can stick our functionality to the code so that we can get these classes to do something. So once I've added this -n, again, the command is in the tutorial readme. Hit enter. And we might need to refresh the view here. And if we do this, we see that we have the sintering.py, which has popped up here. And we can see here that we have a bunch of imports in the beginning here, and then we have the two classes. So we have the temperature ramp class, and we also have the sintering class. And we can see that we have the quantities initial temperature and final temperature, and then that we have this normalize function that I mentioned, which lets us do some functionality in this. This is what we will try to do next. We will stick some functionality into here. Okay, you can also see that we get some complaining here from our IDE. So rough is saying something about import is unsorted or something like this. So we can go ahead and try to. Oops, sorry. If we stand in here, we can hit Control and dot, and then we will get some quick fix options here. So we can do rough organize imports, for example. So this is rough is one of the packages that we installed. And if we do this, we see that rough organizes the packages for all of us here. We can also see that Pylance complains a little bit that it couldn't resolve this, and this is probably because we just installed these things, and maybe this VS Code hasn't picked up that we have a Python environment. So if you have used VS Code before, this is basically a VS Code window in here. So if we press F1 in here, we get this command where we can do a couple of things, and here we can add the interpreter. So if we just say write interpreter, we get Python select interpreter. And if we do this, we can select this .pynv interpreter here. Again, this is not important for any functionality, but this might help you with these things, and then it might take a second or two for it to figure out these imports. But now you see that it actually figures out these imports. It might be useful to be able to follow these references, for example, and see something. So you could follow, for example, this process and see this class and so on as it is inside of the package. That's just some functionality tip for the IDE. Okay, but back to our code here now. We want to try to add some functionality to the normalize function. So let's head back to the tutorial README and see what is it that we need to do to this. Sorry, I forgot one step. So before we do this, add the functionality, we need to make sure that NOMAD can actually find these new sintering classes that we added. If you remember from before, I mentioned that in this init file here, we provided the metadata. So I'll just drag this to the side here so you can see this, the metadata for how we find and load our packages. So what we will do, we see how this is done here for the example M package. I will just go ahead and copy this code that is right here. And then I will just paste it below, and we will basically change it to fit our new package. So of course we cannot call the class the same thing. So I will change the name of this class here to be sintering. It's still a schema package entry point. So this is telling us that this is a schema package. There's a parameter here. This is to be able to give us some configuration for the package. For now, we will not worry about this. I will just go ahead and delete this line. Again, you can read more in the NOMAD docs about what this does. And then here, we need to see, so for what you see here is that from the NOMAD sintering schema packages.my package, we're importing the M package. So this is from the NOMAD sintering schema packages my package. But of course, we don't want to import the my package here now, but we want to import from the sintering instead. So we change this to sintering here. And then we need to change the instance of this. So there's an instance created as well, and this is what we reference later in the TOML. So I will also change the name of this to sintering, and then I will change the name of the entry point class here to sintering. And then of course we can also change the name to something here, and maybe the description. Like this, right? Okay, so to recap, we copied the definition that was there before. We just changed the name of the class to be something different. In this case, it's a sintering entry point, and we made sure to import the M package. So just briefly, the M package is defined at the top here, and this is basically what collects all of the sections that we have inside of this Python file. So we import the M package from sintering here instead from my package, and then we create a new instance here. Save this file, and the last thing that we want to do now is that we need to update the PyProject.toml. So if we go to the PyProject.toml, if you remember here at the bottom, I said we had this NOMAD plugin entry points, and we need to create one now for the sintering. Let's go ahead and copy this line of code here. I will change the name to sintering, and I will change what it's pointing to here. So this is the instance in that init file. So if we go back to the init file, we remember, save this. If we go back to the init file, we saw that we had this my package instance before, and now we also have a sintering instance of an entry point class. And that is what we now point to here to define this class. Okay, with that, we are all done with adding our new sintering classes. So for now, if we were to launch this in an Oasis, we would see our sintering classes. So the same thing as we showed when Andrea and Sartak was showing before with the YAML schemas. We would get the same behavior. We would see the initial temperature and the final temperature and so on. But like I said, we now, of course, want to add some functionality. That's the whole point of doing this plugin, to be able to add some custom Python code for this. And this is what we will do in the next step here in the normalize section. However, before we do that, it could be good to add again this stuff to Git. So we will add all the files with the new changes of the sintering stuff, and we will also commit this. Again, I will just go ahead and copy these lines of code here, and just go ahead and paste them here. And then we see now that these modified things are gone. Okay, so just to recap, we now copied in the YAML code with these classes definition defines in here. Then we installed the meta info YAML to py. and we ran this on the YAML to create this sintering classes. And then we went and modified the init.py and the PyProject.toml to create the meta info so that NOMAD knows that now we are picking up this class. Are there any questions so far? Schema asked, I think I got lost. Why did you create the Pydantic model and load M package out of a NOMAD schema? So the idea here is that we have this Pydantic model in the init.py to provide some metadata around these packages that we load in, so that we can configure these for a NOMAD Oasis later, whether if we want to turn these on or off, if we want to include the package or not. And the reason for having this load function is here is so that we can lazy load this M package, so that we don't need to load this M package in on startup of NOMAD. Because if you have a lot of these parsers and plugins and all of this stuff, this would really slow down the NOMAD Oasis. And then with this lazy loading, we can now only load them in when we need to. And it also helps with some circular dependencies. So if we have, for example, dependencies on NOMAD inside of our packages, which we typically have, then there could be some confusion with circular dependencies if we try to load those before those things have been loaded on startup. Does that answer your question, Schema? Yeah, good. Okay. Yeah, again, just drop questions if you have any. I will move on to the next part. So now in the next part, we want to add a so-called normalize function to provide some functionality in our code. So I've thought up of some use case here. It's just a simple example, right? Nothing revolutionary, but just so that we can see something working. So we could assume, for example, that for this sintering step that we were showing, we have a recipe file for our hot plate that has some list of steps with duration and initial temperature and final temperature in a CSV file. So I will just assume that we have something like this and write code based on this. But again, you have your imagination is the limit, right? You can write any type of Python code that you want to write in there to do any sort of crazy functionality. If you want to follow along with this test case, then again, I suggest that you either make the CSV file or you just copy it from this repository using the curl command here, put it in the tests folder, so that you can also test this along. So I'll just copy this command in here and run it in here. And then we can see that in our tests data folder, we now have this sintering example.csv, which has some stuff. VS Code is asking me if I want an extension for CSV. For now, I will ignore this, but you can install these if you want to have some better functionality for seeing CSVs. And here we see that we have our columns again and everything. Okay, so now we have this file, and now we want to add some code. So in order to operate on this file, we need to access this file somehow. So the way that we will do this is that we will add a quantity to our sintering class where the user can provide this recipe file. And we do this by just doing a simple string type. And then we have an ELN component, which is a file edit quantity. And this file edit quantity then allows us, the user, to drop a file in there and for us later on then to find and fetch that file. So I will go ahead and add this code into the sintering class. So I'll move to the sintering.py here, and I will go down to the class sintering. And in the normalize function here, or sorry, in the sintering class, I will add a new quantity here, which is called data file, and this will be a quantity. And we will say that the type of this quantity should be a string. We can give some description, which is of course important for fair data, so that we know what is in here. So we can say that this is a recipe file for the sintering process. And then we want to, like I said, add this ELN component here to make sure that the user has some way of providing this as a file. So I will do component, and then I will do file edit quantity. This I need a comma here, I believe. Okay, so now we have this this data file here, so that the user can provide it. And next we want to read this, right? So then we go to the normalize function. So this normalize function gets called every time the user saves in the ELN. So if you remember, Sartak was clicking the save button, then this normalize function gets called and we can run some functionality on this code. So the first thing that I will do is I will just check is the data file. So we access this as objects of the self. So we have self.data file and we check, does this exist? Otherwise, it doesn't really make sense to run any of this code. So if this self.data file exists, then we want to open this file to read the data from it. And this is one of the peculiarities. So here we need to use this archive that gets passed in to provide the right context so that we know where this file is actually mounted in Nomad. So I will go ahead and actually copy the code from the README here. And what we can see is that we use a method of this archive, or actually of the end context of this archive, which is called raw file, to open this self.data file. Go ahead and just copy this line of code here. And I will just stick this here. So now we are opening this self.data file as file using the M context of the archive here. Again, don't worry if you don't understand maybe the technicalities of this. There's more tutorials on or instructions in the docs about exactly how all of these things works. For now, you just need to do this. And then we need to read the file, right? And this is a CSV file, so I will just use pandas for this. So I will say df for data frame is pd.read CSV, and then I will just put the file handle in there. And then now, of course, my VS Code here is complaining that PD is not defined, so we need to go out to the top and we need to also import pandas. Import pandas as PD here. And then we go down to the bottom again. So now we have this data frame in here. And now we need to just iterate over the rows in this data frame, and then we can create these steps in the sintering process. So I will make a little list to hold our steps, and then I will just go ahead and iterate over the rows. So I will just go ahead and iterate over the data frame, and then I will create a step. Which in this case will be a temperature ramp. So this is the class that we defined here at the top with the initial temperature and the final temperature. So I will just create an instance so you can work directly with the classes in here to fill these things. So I'll create this step. And then I will fill this step with the information inside of the data frame. So I'll actually just go ahead and copy these lines from here. Code here. Fix the indentation a little bit here. Use tab and shift tab in the editor to do this. Okay, so here we have extracted the step name from the row to get the step.name. And here we see that we have extracted the duration in minutes, and then we have used something called a ureg.quantity. So this comes from Pint. And this gives us a way to handle units in Nomad so that we don't need to worry about this. We don't need to worry about here in the initial temperature. Did we define this in Celsius, or was it Kelvin, or was it Fahrenheit, or whatever? We can just pass a pint quantity in here, and then Nomad takes care of this for us. But we do need to import this ureg. So again, I will go to the top and I will just add from nomad.units import ureg. Okay, and now we go to the bottom here. And then the last thing that we want to do is that, of course, we want to also add this to the list. So we do steps.append step. Okay, so now we only have two things that they're complaining about. So apparently these lines are a little bit long. So again, we can stand in here and we can hit Control dot, or we can actually reformat the whole document. So if we click on F1 again, we can look for some rough commands. And there's a rough command for format document. So this rough is already installed and preset up to follow the Nomad style guides. So we can just hit rough format document. And then we see that rough formats this nicely for us with indenting this and breaking the lines. We don't need to worry about these things and make our code look nice. Okay, now we're almost done. The last thing that we just need to do now, we just have this list of steps. But of course, we want to assign this to the self.steps, which is the actual repeating subsection of temperature ramps. So the last thing that I will do here is I will say self.steps is equal to steps. Okay, and with that, we have no complaints from rough, and everything looks okay in here. And so I think we are ready with the functionality. And then, of course, now we need to test whether all of the stuff that we did works. So that is the next step. So we just can recap here that we did all of these things. We created the data file quantity. We opened the file and read it with pandas. We started to populate this temperature ramp with the different quantities in the file. And we added some imports. And here is the full thing of what we added so that you can also go ahead and look at this. So the next step now is to run the normalize function. But before that, we can check if we have some questions. There were some messages here. Okay, I think this got answered by Andrea. Perfect. Then I will move on. Okay, so now in the running the normalize function, we will test this. And of course, in an ideal case, you set up the tests folder, and there's actually a pipeline already set up for your project, so it will run these tests and so on. But for now, we will just do a quick and easy way by just telling NOMAD to process a test file where we have added a CSV file, and then we will see what this does, right? Whether it works or not. And this is how it ends up being run in NOMAD in the end. So just before we can do that, we need some sort of test file that we can run this on. So these are these entry files that Sartak was showing as these entries in the files tab, if you remember from part 2. And they can be either ending in archive.yaml or archive.json, depending on what markup language you prefer. So I just show how it looks for YAML here, for example. And the important thing is that we have a data section, and then also that we have an mdef, which is pointing to this class that we created now. So we have nomad sintering, schema packages, sintering, and then we have the sintering class here. So if you called your package something other than nomad sintering, then you have to modify this file here if you're following along. And then lastly, we provide one of these quantities in here, which is the data file, and the rest we leave empty, and we hope that these can be extracted from this example.csv. So again, you can just go ahead and copy this from the curl if you want to have this. I would place it in the test/data folder. So I copy this command, go ahead and paste this in here. Run it, and now we can see that we have this test sintering archive.yaml, and again we have the data, we have the path. Again here, make sure that the path corresponds to this nomad.sintering here. And once we have this done, then now we can run the processing on this file. Here we are pointing now to the CSV file, and we do this with the nomad CLI. So just stop it a little bit here. So basically, this is nomad. And then there is a function in there called nomad parse. And this is how we can parse one of these archive.yaml files. And then we will point it to the file that we want to parse. So it's in tests, in data, and then it's the test sintering archive.yaml. And then before we run that, we will add a flag which is show archive. And this flag will basically print out the result of this processing, so that we can see this. And I will also actually go ahead and save this or print this. Happen now. Sorry, it's lagging a little bit here. I will go ahead and save this into a file. And the way you do this in Linux in the terminal is you just write this little arrow here, and then we can save this into the printout of this basically into normalize.archive.json. So I will go ahead and run this. And when we run this, then now it will actually run this load function and load in the plugin, and it will run the processing on this file here. And then we can see that, we get an error here. There's an exec info, cannot convert from milli-inch length to second time. Okay, so we can have a look at in our thing here, and we can see that, okay, so min apparently gets converted to milli-inch. Got to love the imperial units, right? So we will change this to minutes, and this should be processed directly. So here we can see what Nomad was actually trying to do. It was trying to take this milli-inch and set this to second, which was in time. So time. So basically, the step of duration is measured in time seconds, and it couldn't run this conversion here. But from minutes to seconds, it will be able to run the conversion fine. So then we can just go ahead and change this. And because we have installed the package in this editable mode, we don't need to reinstall or anything like this. We just need to hit save, and then we can run the processing again. And then when we run this processing, and hopefully now we should see that this works. So again, it loads in the package here, and we don't see any messages. So this seems like it was running okay. And we can see now that it has created this normalize.archive.json that I chose to save the output in. And we can go ahead and have a look in this file. And here we can see now that indeed we have a lot more information than just the data mdep and data file, but we have also gotten some other stuff. So for example, the name has been automatically assigned here. It has grabbed the current date time, but importantly, it has also added the steps, which is what we wanted our functionality to do, right? So we have now a heating step, a hold step, and a cooling step. And we can see here that the conversion did indeed work. We gave it 30 minutes and it gave us back 1,800 seconds. And the initial temperature and final temperature is all in here. Okay, so now we have our package with our functionality in it, right? Before we move on to the next step of the tutorial, which is the tutorial part 4, where we will actually load this into an Oasis, I thought I would just we should also just commit these changes that we have made now, so that these changes are in the latest version. And again, you can copy this git add if you want. I'll just also show you how you could do this in the GUI already in the VS Code. So if you see here on the left, it says source control and 4, and this 4 indicates that we have 4 files that have been changed or updated. So if we look here, we see that we have 3 new files: the normalized archive, the sintering example, and the test sintering, as well as we have a change to this sintering.py here. So in order to commit these changes, we need to add these changes. So by clicking stage all changes here, this is the equivalent of writing this git add -a. And then we can provide a message, and this is the equivalent of this -m. So here we can write something like added normalize functionality for reading CSV or something like this, right? And then we can choose to just commit it and then sync, or we can just directly commit and push if we want to do that. If you do, I will just create this commit and push. If you do work on this together with other people, it might be good to create branches and so on. Again, there's some links in the resources in the tutorial README on how you would deal with Git at the top there to maybe create some branches and work like this instead. But with that, we are done. We have created our plugin. We have added some schema to it, and we have added some functionality. And in the next step, I will show you how we can actually launch a NOMAD Oasis and run this locally with our new plugin. But before we do that, maybe we see if there are some more questions. I see that there is something here. You can only save it as a .json file. Yeah, it's producing a JSON file. Exactly. You can run a Python conversion, I guess, to convert this if you would want to YAML using the Python YAML package. I guess in principle we could also offer an option to export this as a YAML if we would want that. But in principle, the JSON and the YAML are very similar here in the structure and so on. Someone is asking me too much to get unmuted. I guess that was me. Meanwhile, if there's someone else who has any questions,
you can check my comment. You know what I mean? With the archive file.
What was the comment that you wrote, Sebastian?
This normalized archive JSON that you produced, what that is in context to the NOMAD GUI, as we had this earlier.
Yeah, this is what I said. This is the same as the entry that
okay.
Sartak had. So this is like I was showing you here when we have. Sorry, well, I was running a little bit fast there. Here, this archive.yaml or archive.json. Like I said, these are the same as these files that Sartak was showing in the file browser. And they have this data section where they have the definition and the properties. And these can be either in this YAML format, as we see here, or they can be in the JSON format. But you see that it's exactly the same thing. You have the data, and then you have the properties like the mdef and the data file directory. Yeah, that's good.
Thanks.
So we have
I missed it while following the steps. Thanks.
So Schema could at the end write the question. He's asking about units. So can you, Hampus, comment?
Yeah, or somehow ensuring SI as we do in other parts of NOMAD for interoperability. Yeah, so there is no enforcing of this, right? But what we do recommend currently, this might change, we might at some point enforce it, I don't know, is to stick with SI units, right? So to actually change this here from Celsius to actually would be better to actually have this store this in Kelvin, because in our functionality, we don't need to change anything because we are already using this ureg here from Celsius. So NOMAD will know how to convert this into Kelvin, similarly to how the duration is already in seconds, for example. And then we can also say, if we do want to show this in Celsius, we can use this default display unit here. So there, you see here in the component that we have a number added quantity, like I showed you, but we also have something called default display unit. And this is what will then show up to the user, so that even if the data is stored in Kelvin, the user will see it in Celsius in ELN. And like Schema said, this does actually increase interoperability, because then we know that the data inside of this archive, because right now this is stored in Celsius, and you have to go and check up the definition to know that this is in Celsius.
So I just posted in the chat here the specific line taken from the IKZ plugin that I was mentioning before. And this is showing that every quantity, whatever unit it is written in, is then translated in SI. And so you can see how we are doing that, just in case you are interested, and you can just copy paste that line. It's in your plugin.
Hampus, yes.
Yeah.
If you have some extra time, if you want to give some time to the people to catch up, because it actually it was a lot even for people that deal with NOMAD. So I think we need to.
Maybe I can go on with the wrapping up slides for this part. So we will have it. Oh, sorry.
Yeah. So what you can also show is that in your GitHub repository, like with this plugin connected, it also creates already the docs, and then you can deploy them as a web page if you wanted to document the plugin.
Yeah, exactly. So there's a lot of extra functionality, but I think this will not help people to catch up, right? If I'm showing.
Yeah, this is true. Yeah, okay.
I think we will just do like Andrea said. We will show the wrap up now of this part, and then I will show briefly how you can launch this in Oasis. It's actually quite quick, and then we have some time after that where you are free to stick around. I will hang around in the room. And then if you are still trying to follow, you can of course read the steps here and continue. I will be here to answer questions, and then you can try to continue through this. And then also, if you want to continue later today or tomorrow, we're available on the Discord, so you can also write us there and ask us questions. So with that, I will stop my share and hand over to Andrea.
So thank you, Hampus, for this very nice journey across how to deploy and get to use a plugin. So it was a very nice showcase, and I will now go through a very small recap, just a visual recap of what we just saw. There were several steps in what Hampus showed in the part 3, and we started from the very beginning, that is setting up our GitHub repo. And then we were setting up our Python package within our GitHub repo. And also, as usually when dealing with some Python coding, we set up our virtual environment, and then we installed NOMAD. We wrote a schema, and then we stick to the schema normalizer. That is the main nice feature we get in a plugin compared to a simple YAML file. And then we tested our plugin. So all of this was prepared by Hampus within a very nicely wrapped set of tools that let you just go through the tutorial, through the step-by-step tutorial that is in our repo written in the README. and you can basically execute all of these and get the plugin developed within these GitHub code spaces. We used several other tools around. For example, this Craft is making nothing more than preparing for you a Python package structure. But in principle, you can also just prepare your own Python package if you're familiar with that. Also, another tool we saw is this meta-info YAML to Py. This is used to quickly convert a YAML schema that you may have written one day in Python code, so in a Python schema. This is very useful when you are testing your custom schema with a YAML, and then you are ready to stick some processing to this schema, so some metadata fetching. And so that's why there is this script that Hampus did and is made for that. I don't remember if you already mentioned, Hampus, this, but probably this is going to be soon just a command within our command line interface in NOMAD. So it's going to be integrated within NOMAD, and one doesn't need to use a separate tool. It will be just within NOMAD. So as I said, all this pipeline was prepared and wrapped into these tools that let us do it in a very unified workflow. But in principle, we can also do it manually if you're familiar. And I will leave, for example, in this slide, some example plugin package structures. So there are like the 3 repos that we already showed several times. And there is also this one plugin that we are all working on in our team. And so it's a nice example to look at. And also the schema that Hampus used was the one that Sartak produced like 1 hour ago. But we have already in GitHub several organizations having several repo in which you can see some example schemas, or you can also produce your own schema. So basically, that's the whole pipeline of this part. And yeah, so we arrived to having a plugin.